talked about exponential growth and decay, something that you are very familiar with. Okay? Exponential growth and decay. You talked about it back in algebra, right? At least one of your algebra classes. We'll say algebra 2 and a little bit of pre-calculus. Okay, growth, exponential growth, right? Growing exponentially, exponential decay. Decays exponentially. Okay? I think I just did those backwards, but that's okay. Okay? So, in other words, exponential, the more you have, the more you get. Decay, the less you have, the less you get. Okay? With exponential growth and decay, the rate of change of the quantity is directly proportional to the quantity itself. Okay? If you recall direct proportion from way back in algebra,
What?
no, y is directly proportional to x means that they're related by some constant. Okay? No.
But it's C for constant.
Sometimes K is used to describe a constant. Okay?
Like K. Okay. Smarty. Oh.
So here we go. Here is the rate of change directly proportional to the quantity itself. So we have y. And y is changing over time. Okay? So the rate of change is directly proportional to itself. What have I given us?
I don't know.
Are you recording? Correlation.
dy dt equals ky. Does that look at all familiar to what we did yesterday?
It looks like a rate of
No,
change.
suppose T Y.
We have a differential equations to solve, okay? So please follow along with me. We can divide the y over to stay with the dy and multiply the dt over.
I have a question. Can you write in the colors so like we know what to write down and then if don't so like write in red to write down, but then like write in blue, like you don't need to write stuff.
Okay, red, write down.
So we have to circle that too.
True.
It's up to you.
Well, that's cool.
Now,
It's up to you. We don't have black.
I like doing my integral symbols in different colors, but I will not. Now we need to integrate both sides. What is the antiderivative of 1 over y?
The natural log of the absolute value of y.
Thank you. What about the antiderivative of k dt? K
What's A?
t
Katie.
plus c. Okay.
How's it KT?
So k is a constant. We're integrating with respect to t. When we integrate a constant, we tack on that variable. So if this was 2 the x, antiderivative would be 2x.
Okay, I see.
Okay.
So it's a variable.
Yes.
So it's a constant times 2 plus a constant.
Yes. But k is what we call the growth or decay constant. Okay? So now, let's just stick with me here. When we rewrite, we have technically the absolute value y, okay, equals e to the kt plus c. Now, e to a power is always going to be positive, so we can lose the absolute value, And what we have is a constant times e to the kt.
So, okay. I'm not part of what, okay. Okay.
I mean, it looks like PERT, doesn't it?
Okay.
Yes, yes it does. Okay, so anytime that we know that our rate of change is directly proportional to the quantity itself, then we know, without having to do this again, that our quantity is CE to the KT, where K is the growth or decay constant. What is C going to stand for?
B.
Let's think in terms of like something happening over time.
The population.
The initial amount.
The initial amount. Because when we take e to the 0 power, e to the 0 power is 1. So that C is representing our initial amount.
It's like per, so it's like exactly like.
Yes, it is exactly like PERT. That's what it is.
Bert.
Oh, wow.
Oh my God.
That's very
Should have
disappointing.
used the magic pen.
Yeah, it would have disappeared. Yeah, you're making it like, this is really killing me.
You're like,
Well, I was all excited for it to like stay where it was, and it didn't happen.
no.
Okay. The rate of change of y is proportional to y.
Okay.
That means dy dt equals ky. Now, we don't have to go through that process anymore, right? This, we know, automatically means that y equals ce to the kt. Okay, so now we know when t is 0, y is 2. When t is 2, y is 4. What is the value of t is 3? Okay. From here, it's just an algebra problem. We've done the calculus to set the groundwork, okay? Now we're just doing algebra. A nice, easy algebra day for you on a Friday. Okay? When t is 0, y is 2. So c is 2. I'm going to circle this in blue so we can use it later.
Ooh,
But it's blue, so you don't need to circle it.
that's right.
That was cool.
Green means if needed.
Now, when t is 2, y is 4.
$2K, 2,000.
Okay? So 2 equals e to the 2k, which means the natural log of 2 equals 2k. So our constant is the natural log of 2 over 2. Because we found it right here. So you're going to have to figure out what that initial amount is, that C, before you can plug anything else. We have to figure out what C is, and we have to figure out what K is.
And then we
So we're always going to need 2 pieces of information. Okay? So what I would do, if I were you, you can either leave it like this, or we can put it in our calculator. Have I shown you how to store numbers in your calculator?
No.
that's 4.
So here's the natural log of 2 divided by 2. So we can approximate K to be 0.34657. Since this isn't a final answer, go out to more than 3 decimal places. And then just to be safe, you can store it in your calculator like this. Is everybody watching? STO, that means store. So you can hit store, alpha. I'm going to put it in K because that's what value it is.
Okay.
So anytime I press alpha K,
Hey.
it's going to be that number.
Now,
Life changing.
I'm gonna do it.
I don't know how to do
Then
it.
is C always gonna be, so K will
I'm not gonna
always be
bother
that.
with it.
Okay, and I know in the 84 you can like arrow up and like choose an answer from before, right? I mean, same concept.
But isn't K always gonna change depending on the constant?
Whoa.
But for this problem, this is what K is. So now we have y equals to e to the 0.3467 t. That is our equation now. And now we can figure out what y is at time 3 by plugging in 3. So what I'm going to do with my calculator is I'm going to say 2 times e raised to the k times 3. Oh.
I think you could send one to that.
Better?
Yes.
So we have 5.657. Hooray.
Yes.
No,
That one. We only have 2 more examples.
No homework Friday, right?
Yeah, I don't feel your homework. Because you did write homework for other classes like Thursday.
You have homework today. Don't you worry. Read your example 2, please. Please drink water in here.
I remember doing this in
Iron Man. Half-life triggered.
Oh, man. So here we go. Excuse me, I'm starting to lose my voice. Allergies are
drink water.
terrible. I am. Thank you. I don't know if you realize how much water I drink.
Drink water.
This guy holds 64 ounces, and I drink 2.5 in a day.
Maybe you should go to 3.
Thank you for your.
Go all out. That's push.
Suppose 10 grams. Okay, you already read it. Anytime we have half-life, half-life represents exponential decay. You've talked about that in science class, right?
And also says decay.
So would it be negative then if it's D?
Well, okay. So we know we're going to deal with this. What should be true about K? K will be negative because it's decay. Okay? So if 10 grams was the amount released, what does that mean?
Initial.
Okay? That means when T is 0, Y is 10, our initial amount is 10. Okay? So now we can write Y equals 10 e to the kg. How long will it take 1 gram? How long will it take to decay to 1 gram if the half-life is 24,360
So our Y equals
So our Y equals 1.
So our Y equals 1.
Our time is.
That's what we want to find.
we want that.
We want to find when our Y is 1. We're going to have to figure out K by using
24,000.
That's what I was gonna say, Ms. Homer.
the half-life.
Yeah, you will.
Half-life means what?
How long it takes for half an initial amount to become half-life.
Okay, so if we begin with 10, then it takes 24,360 years to get to 5.
I was gonna say that.
Okay, so we have 1/2. Now, let's talk about this real quick. Whether we knew the initial amount or not, when we take how much we have divided by how much we begin with, if it's half-life, what is this going to be?
Always gonna be half.
Half. If it was like some other percentage, okay, when you take the amount you have divided by your initial amount, that's the number you should get right there.
Isn't it negative 50?
Well, K should be negative. So whether,
Put the L in there. Keep going.
okay, so whether you label this as e to the negative kt or you write it as e to the kt, your exponent's going to be negative. Okay, I would just write it as e to the kt and expect a negative value. Since 1/2 is less than 1, the natural log of 1/2 will be a negative number because 1 is where the natural log approximately is at. Okay, so the natural log of 1/2 should equal. Oh, what's our time? That's what I'm thinking.
Okay, that makes so much more sense.
Yeah, I forgot to write that in. So, our K value. Natural log of 1/2 divided by 24,360. That's very small. So I'm going to store again in alpha K. So what? Point, negative point. Right?
We keep it
Keep it in,
inside the yard.
we have to.
I mean, it's fine if you do scientific notation. Keep it in your calculator though. Since this is such a small number, okay, if you round it even just a little bit, it's going to affect your answer, okay? So store it in your calculator.
We just keep writing that down. Yeah, that's what I was saying.
Yes, you could also, like if you write K as natural log of 1/2 divided by 24,360, that is also fine, okay? So now we want to figure out when it will be when we have 1 gram. So 1, like you said, was our Y. I'm going to write KT. I know we know K. Okay? So how are we going to do this? Divide by 10, right? Then we'll take the natural log of both sides. With your calculators, please figure out how long it's going to be. For this example, time is in what?
Years.
Years. That's not going to always be the case. Sometimes it'll be hours, sometimes it'll be minutes, sometimes it'll be seconds, sometimes it'll be years, but it'll establish that in the problem.
Whoa.
Jimmy, what'd you get?
5,600, 56,570.
Disagree.
80,000.
Yeah.
80,922.1683 years.
I'm going to round up because I'm kind of better than
Would it be?
Okay, do you want here? I'll write it. 922 point what?
49,839.17.
Just right, yeah, there you go.
You've been so helpful.
That's a lot of years.
Yes. So, well, it took 24,000 years for it to cut in half. Does our answer make sense?
Well,
Okay? If we think about exponential decay, the less we have, the less we're going to get, right? So as time goes on, if it's decaying, it's going to decay less and less and less and less.
Never get to zero.
Yes.
Was it 5?
So it's imagine.
What five?
Like 5
Okay. Because we began with 10, and we're talking about half-life. So this number, the 24,360 years, is its half-life. That's how long it takes to cut in half. So half of 10 is 5. Whether we knew the 10 or not, if it's half-life, we know that y divided by c will be 1/2.
So what just put it as a number?
Okay. One last example.
B.
Please read through this. Oh my goodness. Okay. They have told us the rate at which the acreage is being consumed is proportional to the number of acres already consumed, which means we're working with that dy dt equals ky, which means we know, based on what we did at the beginning of class, that y equals c e to the kt. Right? Okay. So we know that k should be negative. Okay. Do you like to label it as negative right now? You don't do that. Okay. Well, I don't care what you do, whether you label it as negative or not. What worries me about when you label it as negative, that if you find it in your calculator and you keep it as a positive in your calculator, then that's going to mess you up. Okay. So we know that there are 2 acres consumed when t is 1. Which gives us that. And we know 3 acres are consumed when t is 5. We want to know how many
What's your
acres will be consumed when t is 8.
Because 2 is 1.
Oh, right.
So this is when t is 1. This is when t equals 5. Okay. We need to know what c and k are before we can plug in a value for t and figure out the amount.
Solve for K and then.
Yes, we have 2 equations and 2 unknowns.
Solve for 1 for K or C and then
I solve for C first.
Okay, we could solve for c very easily in this one, couldn't we? 2 over e to the k equals c, right? Which means here, if we plug that in, 3 equals c times e to the 5k.
The e's and k's would cancel.
I would not say that necessarily. Technically, we're dividing these, right? What do we do with exponents of common bases when we divide? So this becomes e to the 4k. So 3 halves equals e to the 4k, correct? Running out of room here. So the natural log of 3 halves equals 4k. What is k?
You're actually confused what you look for. Screw
So I'm going to store that in my calculator to use for later.
Yeah, we got the same answer.
Excellent. Now we can come back here and figure out what our C value is, right? Oh, we can come back here. This would be easier. So now 2 over e to the k equals C. I just rewrote that. That's all right. So what is C? What is 2 divided by e to the k?
Equal to 3.
Okay, so I'm going to store that in alpha C to use later. But for now, we'll write our equation as y equals 1.80720 e to the 0.10137. Now that we have C and K solved for, we can figure out how many acres will be consumed when T is 8, right? So all we have to do is say C times E raised to the K times T, which we're going to plug in 8. And what is our answer?
C.
Did you guess to begin with?
She said, I said B.
I was gonna say E.
Straight down.
Okay. Question? Yes.
I was just confused on like how you know like which is worse. Like how do you know Y is something versus C is something
Could you?
like how do we know that like where it says when T equals 1 and 3 acres consumed, like how do we know Y is 3? Like why is Y?
So, because that's the amount. So in the problem, the rate at which the acreage is being consumed is proportional to the number of acres already consumed. Okay, so that's like when we talked in that very first introduction, the rate is proportional to the amount left, right? And so the dy dt equals ky on that very first page. Okay. So since that rate is proportional to the acres being consumed, that's our y. That's telling us that's our y.
Alright.
Because that's what it's proportional. Does that make sense?
If I need help on more problems.
Okay. Yeah, maybe looking at another example that said it instead. Is there another question? So, here's your homework. I'll make it bigger. Hold on.
Can't see it.
Hold on.
You can't see it, so we can't do it.
Oh, kind of forgot to highlight that.
You can like 70.
What, you really can't see that?
No,
You should have measured.
I didn't wear my glasses today. And I don't have contacts.
You don't wear glasses.
How do you know?
Oh, but she has information all of our.
Is that a 3-7?
Maybe you should come closer then to me if you can't see it.
No, that makes it worse.
Better not overload you.
She's a teacher, Zach. You do whatever she wants.
She didn't want to promise the
How big is the finger? Oh, goodness.
Where is Brady?
That's Jackson. Hey,
why I asked. Somebody last night. Good boy. Did he live for Knox?
Corey said, I'm not paying $20 for that.
What do you do for this one?
Here, how much? No, he said it all.
I heard one last time I was on.
No, I think it's hard.
Looked like you go to Walmart.
Oh,
Why
wow.
don't you fire up?
Drew beat you on the last one.
We don't have one. You could go. You could go to and
Okay, I am gonna add 2 more problems though. I'm sorry.
harder.
Too late, already run.
Do you want to take 21 or 22 off? Because we didn't do those.
No, you really do.
So I'm gonna add in 29 and 31. I'm gonna add in 29 and 31.
So is that?
And I'm gonna take off 65 and 66.
So you took out 50.
Okay, I like this better. Oh, I'm still recording. Hi, Brady. Bye, Brady.
Brady.